Hi, I'm Beth from my tutoring bee, and today we are going to be talking about special right triangles. So let's get started. So here I have a 30, 60, 90 triangle drawn out, and what I mean by 30, 60, 90 is that is the measure of each of the interior angles. So we can see here that this is our 90-degree angle in this corner. Our smaller angle is going to be the 30-degree angle, and our larger angle is going to be the 60-degree angle. So that's what I mean by 30, 60, 90. And we're going to use the Pythagorean theorem and some geometric proofs to prove some of the side lengths of every single 30, 60, 90 triangle. And this is really useful because when we come across these triangles, we can apply these particular lengths to the lengths of those triangles to solve for it. So we don't have to go through this entire process every time, but I want to show you what the process is to show you how we get these numbers. So what we're going to try to prove today is that the hypotenuse, or the side that is opposite of the 90-degree angle, if that hypotenuse is length x, then that means that the shorter length, or the side that's opposite of the 30-degree angle, is going to be x over 2, or in other words, half the length of whatever the hypotenuse is. And then if that's the case, that the other side, the side that's opposite of the 60-degree angle, is the square root of 3 of x over 2 times x over 2. So whatever the shortest side is, which is half of x, we would multiply that times the square root of 3, and we would be able to find the length of that side of the triangle. So let's start with an equilateral triangle. That's the best way to start this, to begin to prove this theory. So I'm going to try to draw an equilateral triangle as best I can. Let me scoot it over just a little bit. Okay, so we are just going to assume that all sides of this equilateral triangle equal x. Equilateral triangle means that each side has the same length, and it also means that each interior angle is the same. So we know that the interior angles of a triangle have to add up to 180. So if we split that into 3, 180 divided by 3, that gives us 60 degrees. So we know that each angle is 60 degrees. Great, so we've got our equilateral triangle set up here. And now what I'm going to do is I'm going to cut this triangle in half vertically. So what I'm doing is I'm splitting this triangle right down the middle, starting at this top point. Let me label the corners of this triangle as well. That will make this easier. So we're going to label this A, B, and C. And then we're going to split this triangle down the middle here. And so let's talk about what we just did there when we cut this triangle into two smaller triangles, essentially. When we call this an altitude, when we drop a line down that bisects each of the angle, and it bisects the bottom length of this triangle, or line AC. So what happens here is, one, we've cut this 60-degree angle in half, right? So now we have two 30-degree angles. So this would be 30, and this would be 30, okay? Another thing that we've done is, by dropping this perpendicular to the bottom length of this triangle, we've created two 90-degree angles down here, okay? And then the other thing that we've also done is we've taken this length AC, or this length of x, and we've divided it into two parts, two equal parts. So and then we could say that this length is x over 2, and this length is x over 2. By the way, I'm using these little lines here, as you saw when I originally drew this triangle, that I put just one little dash through each of these sides, and that's to show that each side is congruent to the other. And so for the two that have been bisected down here, I'm putting two dashes to show that these two are congruent to one another, and that they're different lengths than the x length. That's all that means. Same thing with the angles. I put one little arc here to show that each one of those is 60 degrees, and then the two arcs just shows that it's, oops, I forgot my little degree symbol, that it's a different measurement, and that these two 30-degree angles are congruent to one another. So that's all that means. So we can start to draw some parallels between this figure that we have constructed over here on the right to the original triangle that I drew over on the left. We can see that we now have, if we're just looking at this one triangle, let me see if I can highlight it here. If we're just looking at this one triangle, that we have already started to construct a 30, 60, 90 triangle, because remember that box right there represents 90 degrees. So if we're looking at this one part that we just constructed, we already have a 30, 60, 90 triangle. So we can see that our hypotenuse is x, and then down here, the side that is opposite to angle 30 is x over 2. So we're already starting to see those correlations. We've got x as the hypotenuse, and then our shorter side is x over 2. So now let's talk about this side that's in the middle here, this side that is opposite of the 60-degree angle. And this is where Pythagorean theorem comes in. We know that Pythagorean theorem is a squared plus b squared equals c squared. And if you need any additional help with Pythagorean theorem, I do have a video that is solely dedicated to Pythagorean theorem, so please check that out. So let's plug in some of our numbers. We know that the two legs, or the two sides of the triangle that make up that 90-degree angle, those are going to be our A and B sides. So we have, let's label this other point down here as well. We need that point labeled. We'll label it D. So we're looking at the length of BD, right? So we're going to call that our A squared. So we're going to plug that in as BD squared, okay? And then our other leg of the triangle, the other side that creates that 90-degree angle, is this, which we already know has a length of x over 2. So we're going to add x over 2 squared. And then that equals our hypotenuse, c squared, which we already know is labeled x. So we're going to plug that in as x squared. So you see we're just taking these variables and numbers from the triangle that we've constructed and have substituted them in for the Pythagorean theorem. So let's start to solve or simplify this. So BD squared, we're just going to write that as BD squared. X over 2 squared, that just means it's being multiplied times itself. So that would give us x squared over 4, right? 2 times 2 is 4. X times x is x squared. And that equals x squared. So now let's start to simplify, because remember, we are trying to solve for this variable, this length BD. That's the one that we're trying to find out. So that means we'd have to get rid of x squared over 4. Well, we need to subtract that from this side as well. So let's make this x squared into a fraction that has like terms. So we can put this as 4 over 4, right? Let me see if I can write that a little bit clearer. So what we're doing is we're multiplying 4 over 4, which, as we know, is just equal to 1. We're allowed to multiply 1 times any number because it will give us that same number. We're multiplying 4 over 4 in order to make it have a common denominator, so that we can now subtract x squared over 4, because we need to keep both sides of the equation equal. Well, what's 4x squared minus 1x squared? That's going to give us 3x squared over 4. And that equals BD squared. So we've canceled this out, and then we've simplified this to 3x squared over 4. Okay, now we just have to take the principal root, find the principal root of each side of our equation. BD squared, the principal root of BD squared is going to be just BD. The principal root of 3, but we're just going to write that as square root of 3. The principal root of x squared is just x. The principal root of 4 is 2. So now we have that BD equals the square root of 3 times x over 2, which is what we were wanting to try to show or prove over here, that the length of the triangle that's opposite of the 60-degree angle is the square root of 3 times x over 2. Okay, so we just did all of that algebra, tried to prove all that this 30, 60, 90 triangle, the lengths of the sides of a 30, 60, 90 triangle are x over 2, and square root of 3 times x over 2. So what does that mean? How do we apply that to other 30, 60, 90 triangles? So let's look at that. So here's a triangle that we're given, a 30, 60, 90 triangle. We can tell we've got the 90 degree here, 30 and 60, and we are given just one length. The hypotenuse, we're told, is length 8 units. I left this over here so that we could refer to it as we figure out. We want to find the lengths of these other two sides of this triangle. So all of that work that we just did, now we can apply that to this triangle. Well, we know that this side is 8, so then that means that this shorter side, or the side that is opposite, of the 30-degree angle, is going to be whatever the hypotenuse is over 2, right? Or let me actually plug that in there. So it would be 8 over 2. Well, then we can simplify that and find out that that is 4. So the length of this side is 4 units. And so now we can take that information and try to find the length of the side that's opposite of the 60-degree angle. So now that we know that the shorter side is 4 units, then we know that this side is going to be the square root of 3 times whatever that shorter side is, because we know that it's square root of 3 times x over 2. Well, we know that x over 2, or 8 over 2, gave us 4. So we have 4 square roots of 3. So we've got our two sides solved after we were given this side of the length of 8. You would be able to find out any of the other lengths if you were given one of the other sides. Let's say if you were given this side instead and we didn't know that this was 8 and we didn't know that this was 4, we could work our way back around just using these special right triangle rules. Same with the others. If we were given that this side equals 4, we would be able to figure out the other two sides by just using that one given side. So I hope that this video was helpful for you and you've learned how to use special right triangle rules for 30, 60, 90. Up next, we're going to be talking about another special right triangle, which is the 45, 45, 90.